All right, let's jump right in. Have you ever wondered how we know what Mars is made of, or how a satellite from space can spot a single patch of sick trees in a huge forest? Well, the answer lies in a kind of hidden language that's written in light. What if I told you that we could identify almost anything just by looking at its unique optical fingerprint? That's exactly what we're going to break down today. To really wrap your head around this, let's put on our detective hats for a second. Imagine you've got a mystery to solve, but you can't get anywhere near the scene. You can only look at it from way up high, maybe from a helicopter or even an orbiting satellite. How on earth do you find the clues? How do you figure out what happened? And you know what? This is pretty much the exact puzzle scientists face all the time. They can't just, pop over to Mars and grab a scoop of soil or take a sample from the middle of the ocean. So, how do they pull it off? This is the central mystery we're going to solve. Well, the answer, the secret clue, is something that every single material, and I mean every material, is constantly broadcasting out into the universe. It's what we call an optical fingerprint. And once you know how to read it, the world's secrets start to open up. And this right here, this is the whole game. Seriously, just like your own fingerprint is completely unique to you, everything out there, from a blade of grass in your backyard to a strange rock on another planet, has its own one-of-a-kind way of playing with light. And of course, there's an official name for this. It's called a spectral signature. And all that means is it's that unique pattern, that special dance that happens when light hits a substance. This signature, that's our key piece of evidence. It's the smoking gun that lets us identify stuff from an incredible distance. Okay, so great. Everything has this fingerprint. But how in the world do we actually read it? What's the science that lets us lift this print from, millions of miles away? Well, it turns out it's actually a pretty straightforward process. So how do we read this fingerprint of light? Well, it all boils down to three really simple interactions that happen anytime light hits an object. Okay, so first, you've got reflection. That's just light bouncing off. Simple enough, right? It's what gives things their color. Then, some of that light gets absorbed, kind of like a sponge soaking up water. And finally, stuff can also emit its own energy, usually as heat. Now here's the kicker. Every single material does these three things in its own special recipe, its own unique ratio, and that is the secret to its identity. And this is where it gets really brilliant. When scientists measure all of that, the reflection, the absorption, the emission, across the entire spectrum of light, and I'm talking way beyond what our eyes can see, they can plot it all on a graph. And that curve that shows up on the graph, that is the spectral signature. That is the fingerprint, visualized right there in front of you. All right, so now we know how to get the fingerprint. Let's do what any good detective would do next. Let's bring in a few suspects for a lineup and compare their prints. And here's the most important thing to remember. Different materials are going to give you totally different looking curves. I mean, no two are exactly alike. The shape of that curve, that's everything. Okay, now this is where it gets so cool. Just look at these differences. Take healthy plants, right? They gobble up red and blue light to grow, but they reflect a ton of near-infrared light, the stuff we can't see. That's why their signature has that big spike. Now look at water. It's basically a light sponge. It just absorbs most of it, so its curve is really, really low, flat. And then you've got snow, which is the complete opposite. It reflects almost all the light we can see, so its signature is way up high. See? Every single one is totally distinct. So there you have it. We've got the clue, the fingerprint, and we've got the method for telling them apart. Now it's time to circle back to our original mystery and solve the case for real. And this is how they put it all together. Scientists have spent years building these massive libraries, these databases, filled with the known spectral signatures of, well, almost everything, from quartz to sand to different kinds of plastic. So when a satellite or a rover on Mars sends back a new, unknown curve, it's just a matching game. They scan their library, find the fingerprint that matches, and boom, case closed. They know exactly what they're looking at. And the ways we use this are just mind-blowing. This isn't just theory. It's how we discovered minerals on Mars that hinted at an ancient watery past. Think about farming. You can spot crop stress from a satellite weeks before you'd ever see it with your own eyes. That saves entire harvests. Or spotting pollution spills in a river from a plane. Or finding where to mine for minerals without digging a single hole. It is absolutely a game changer. So, if there's one thing you walk away with, it should be this. A spectral signature is literally an object's fingerprint, just written in light. It's that simple curve on a graph that tells us the entire story of what something is, no matter how far away it might be.
And that just leaves us with this one kind of fascinating final thought. We are constantly adding new fingerprints to that library, every single day. So it makes you wonder, right? If absolutely everything, from a distant star to a single living cell, has its own unique signature, what other secrets are just floating out there, waiting for us to learn how to read them?